Cat, can you stop making noise? I need you to be quiet for the video. I'll pet you after, okay? I promise. Welcome to the first devlog of Project Zor. It's a placeholder name because I'm not really good at coming up with those. Now, this game is the new open world RPG that I'm working on. The reason for that and the backstory is in the last video, and I went over my previously released, why can't I say that word? The reason and backstory for that is in the last video, where I went over how and why I started game development, and then including the reasoning for why I'm doing a much bigger project. And from those previous experiences, I've decided that this game is going to be single player. The backbone of the world and the story is developed, but I'm saving a dedicated video for the story once it's more ironed out and detailed. So in this video, I'm going to be showing off the animations I've been working on for the player, then we're going to get into some technical programming juiciness with the AI. And don't worry, the videos and pictures are included. It doesn't matter. I lose half my viewers in the first 15 seconds anyway. I didn't even know I could do this. Boing, boing, boing. Welcome to the new scene, which actually took me the longest for this video, because I had to rebuild support for the high definition render pipeline, which Unity came out with and we're using for the game. I also spent a bit working on these cool interactables. So now we have an interaction system. Why is it throwing it backwards? Hold on, something's not right. Alright, well, we'll just ignore that. Okay, as I said, my first animations, okay. But yeah, I think they're pretty good. They're obviously just placeholder animations that we'll use for the demo, so they don't have to be perfect. Is that guy playing the idle animation? Oh, there we go. Idle animation, perfect. There we go. Wait, can you see that? I don't know. Get out of here. Oh god. Nope. Hold on. Wait, I got this. No. There we go. Alright, idle animation. Now, because of the way the rig has been made, we can't use things like Mixamo, which is a great resource if you have a standard humanoid rig like this robot. Ooh, I have been waiting way too long to do this bit. This is a key to the first game I ever released on Steam. So, yeah. And it's on a key. Get it? Oh god, it's so fucking dumb. It's the best I can come up with. Can we just cut to some gameplay? With the basic set of movement animations done, I plan to create the placeholder combat animations this week, and then next week spend some more time doing coding for the combat. The reason I'm saying all these animations are placeholder is because the model might change, or somebody else who's actually good at animating and has experience will join the team and redo them to be a lot better. Otherwise, you know, I might spend a month polishing them myself, but I'm capping the time I'm allowing myself to work on this, and so the end product of whatever I work on is the end product. I'm prioritizing the gameplay. But anyway, with that out of the way, let's get to showing off the cool AI stuff. Okay, so I've set up this little showcase here for the AI. This is the test NPC. He's patrolling around his little precious artifact, and you might have seen him in previous updates that I've been posting in the Discord server. He'll chase the NPC if he sees it while patrolling, but he can't right now unless I move these cubes out of the way. Alright, and there he goes. Now before he reaches our friend here, I'm going to stop him here with my hand. Alright little buddy, run away. Because our enemy can't see him anymore, instead of giving him X-ray vision, he's just going to go to the last seen position of the NPC. And then after searching for a bit, he'll forget about him and go back to patrolling. So all the logic starts right here inside the fixed update loop, which iterates consistently over time. Once our timer runs out, we're going to check for nearby targets and then check our field of view for targets. Now the reason we do this is so that we don't check our field of view for every single target in the world, but only the ones that are nearby. Checking for nearby targets is just an overlap sphere around our position within a radius and then a layer mask so that we're only searching for objects that we actually care about. After caching that, we're going to check the field of view for targets. But before we loop through all the nearby targets to see if we can see them, let's try and test for a couple other scenarios first. The first one is if we're already looking for something and the distance between us and the last seen position of that target we're looking for is less than or equal to the distance we think is fine for us to stop looking. Now, if that's true, if we're patrolling God, I cannot speak this morning. Now, if that's true, if we're patrolling AI, let's go back to patrolling, else let's go idle. The next scenario we need to test for before looping through all the targets is if we're already tracking one. Now, if we are, let's calculate if they're still within our field of view. We calculate that by taking the vector2 angle between our AI's transform.forward vector and the vector between that AI and its target, which is just the target's transform position subtracted by our transform position. And if that is less than or equal to our field of view divided by 2, and we want to divide it by 2 because our transform forward vector is within the middle of our field of view. Then we're going to want to shoot a line to see if we can still kind of see our target. And if it does hit our target, let's set our path to it, cache some information, and then try and interact with it. But before we look at the interaction logic, let's look at the very last part of our field of view checker function. This is the part where we know that we're not looking or tracking for something. So now we're testing if we should start doing that. We're going to loop through all the possible targets that we cached earlier, and if one of those targets is within our view distance and within our field of view, we're going to figure out all the stuff in between us and that target using the raycastAll method. Now, there's something you probably want to know if you're ever going to be using this method, is that it never returns the hits within the order that it hit them. So I solved this by creating a method that loops through all the hits and then returns the one with the least amount of distance. And then we're going to again try and interact with it. Now, this try interact function is just going to call the interact function with the correct type of what we're interacting with. So whatever AI this script is attached to is now going to try and figure out the interaction between it and its target. Since we've called this with the correct type, we know how to grab that target's faction. And then all we do is call the targetable interaction manager, which each scene has, and it will return the type of interaction that we have with the target. Then we're testing if we're hostile and we're armed, then we should target it, else we should try and run away. Now, if we figured out we wanted to target this object, we're gonna start chasing it and then figure out if we want to attack it. If it's within range, we're gonna call the idamageable interface take damage function. Now, this is a very useful thing you can use inside of C#, which is basically like a contract you can assign to any script, which would make it inherit very specific function calls. So when we define our base AI script, we do inherit the damageable interface. So does the player. So that way, if a script has the damageable interface, we can say, hey, script, take damage. We know each script that has the damageable interface has the take damage call. But inside of each script, we can customize what's inside of that call. Now, for example, this die function is on an AI script. So I can say, all right, play a dying animation. But if this die function is on exploding barrel, we're gonna say, all right, now spawn a big explosion special effect and damage everything within a certain radius. So that about concludes the stuff about the AI and animations I want to show off. Tomorrow and the day after, I'll probably be working on combat animations, and then next week we'll be focusing on some more visual and combat coding. For this project, I'm targeting medium to high-end machines with Unity's new high-definition render pipeline. Things like volumetric fog and light. Not quite ray tracing, but I recently played around with subsurface scattering and light cookies to create some pretty interesting things with like leaves and light. It was all inspired by this random GIF I found on Reddit while procrastinating and, well, browsing Reddit about these like trees and lights moving, which just inspired for the whole process. And that about concludes all the stuff I wanted to show off. You know, we got the animations and AI. There wasn't much gameplay to show off, but during this week I will be working on combat animations, and then next week will be more programming combat, and then maybe focusing on visuals if we got the time. There's a lot of exciting stuff coming up, and I want to get a demo finished before having to get a job and save up for moving out. The best case scenario I'll probably have is landing a remote or local game dev job at Austin. Probably end up working a random job in IT or flipping burgers while trying to make game dev sustainable through things like Patreon and game sales. But anyway, I hope your day has been made a little more awesome. Now go tell someone you love Happy Valentine's Day or something and do the same for them.